So this next example I decided to just create. I wanted to bring in something a little more close to home, but I would do recommend checking out example 3 in your text as well. Okay. It's a similar kind of problem. So the tools are going to be the same, like the setup is going to be very similar, but that one's on toll roads instead. So check it out. But this one I did a little bit of research and I had summer on my brain, so I thought it'd be fun to bring it in. So Crane Beach is a popular beach in Ipswich, Massachusetts. So if you've never been, it is a pretty popular beach in that area. And we're going to say that you're a person who loves to go to the beach and you try to go as often as you can. But of course, you're pretty busy, so you don't get there as often as you like. I know that happened to me this past summer. I got to the beach for about a week and then I never went again, which was really sad. It was just a busy day, busy summer. So to park at Crane Beach, you can either do one or two things. You can pay per day, and it's quite expensive, or you can buy a membership and then you get to park for free. But that's also expensive. So it's something to consider, right? How many days are you going to go to the beach? Is it worth it to buy the membership or is it worth it to just pay per day? And this is something that I myself have thought about, not particularly at this beach. I did not go to this beach this past summer, but I've thought about, do I want to pay for that subscription? Should I pay for that subscription to the gym? Should I pay for that subscription to the beach or to something else? Is it worth it? Am I going to go enough times? And that's what this looks like. And the example in your book is very similar, where you're paying to cross a bridge. So you're deciding, okay, should I pay a little bit more for a monthly plan, or should I just pay as I go? How many times do I have to cross that bridge to make it make sense to get the monthly plan or to have it even out? So for Crane Beach, to purchase a parking permit, you have to first be a trustees member, and that membership costs $50 for an individual. And then in addition to that, then you can purchase a parking pass for $85. Alternatively, you could just pay to park each day, which costs approximately $45 per visit. So it does have a little bit difference between parking during the week and on the weekends. And I won't lie, the prices have gone up since COVID. So you can either pay $45 for a visit, or you can get these two memberships together and then you can park all season for free. So our question is, how many times would you have to visit the beach in order for the cost to be the same? So our goal here is to find the number of times needed to visit the beach for the cost to be the same. So you're looking for one thing here, and basically you're looking for the number of times to visit the beach. So that's going to be our X value here. So let's think about our two costs for a second. So if we get a membership, we have two costs. We have to pay $50 first to be a trustee, and then we also have to pay $85 for the actual parking sticker to go along with it. So we're going to do that. And then, but once we do that, then the beach is free. Okay. So once we make that initial payment, then we don't have to worry about it anymore. Okay. But $135 is a lot of money up front. So we really want to make sure we're going to visit that beach. If we pay per day, the cost is $45 per visit. And my question is, I want to know, when are these the same? So when is the cost of membership equal to the pay per day cost? So now let's finish setting up our equation. The membership cost is just $135. I don't have to worry about paying additional fees in this particular case. Sometimes if you have memberships, you still may have to pay a small fee, right? So maybe you pay a membership up front, but the pay per day cost goes down or something like that. And you'll see an example like that in your book with the tolls. But for this example, the membership is just $135, and then you don't have to worry about it again. The pay per day cost is $45 per visit. And remember, we don't know how many times we're going to go. We're letting X be that. So it's going to be 45 times X. Okay. So here's our example here. This ends up being actually a pretty simple equation once we work out all the details. And to solve it, I'm just going to divide both sides by 45. Now, this is one, again, you can take out your calculator. I already have it done, but I'll just show you anyway. And all you're going to do is type in that 135 divided by 45, and we get an answer of 3. So when we go to the beach, three times, the costs will be the same. Now, in the real world, this is information. So I do think about these things when I think about memberships. So for instance, I have small children. COVID changed that a little bit, but when they were younger, we used to go to the aquarium a lot in Boston. And I used to look at the numbers and say, okay, should I buy a membership for the year and then I can go for free? Or should I just pay per visit? Maybe I'll get a library pass or figure that out, or maybe I'll get a gift card, hopefully for someone's birthday. And I would really actually crunch the numbers and see what's worth it. How many times would I have to go to the aquarium to make that membership pay for itself? So here we would need to go to the beach 3 times. So if you think, hey, I know I'm going to go to the beach at least once a week, that's way more than 3, then you know your membership's a good deal. If you think to yourself, well, I'm really busy this summer, I may only go 1 or 2 times, then paying per day is probably going to be your better option. Okay, so this I like is a nice application because it's something that I actually do a lot. Surprisingly, there's a lot of situations lately where you decide, should I pay for that membership, right? Is it worth it? All right, let's change gears again. So what we're trying to do in this section is to show you some different types of examples, right? So we've seen the first one where you have multiple unknowns. You kind of had this totaling idea. The last video, we also saw one where we had a time, right? A starting time and a change per year. Here we just did a comparison, comparing one of these 2 values equal. And next I'm going to do a percent. So it says your favorite electronics retailer is having a terrific sale on noise canceling wireless headphones. After a 40% reduction, you purchased the headphones for $192. What was the price of the headphones before the reduction? So there's our goal, there's our question. So we're looking for the original price, which is before, so that says before the sale of the headphones. A lot of times when we're talking about discounts or even markups, we talk about the original value. So the original value is your starting value here as well. So in this case, the price went down, it was reduced. So the original value would be before the sale. And you want to be really careful here. What most people do is they see 2 numbers, they see 40% and they see 192 and they multiply them together and they move on. And that's not always the case. And it's not the case here. You have to be careful and think about what's going on. So in this particular problem, think about it. You have headphones, they're getting marked off 40%, and the final price is $192. And we're not worrying about taxes here. So let's pretend we're shopping up in New Hampshire, so there's no sales tax. We're not worried about taxes. So it's just the reduction. The question asks for the original price. So think about this. When you go shopping, they have an original price. Then you subtract out that discount. And then you get your sale price. So what I have here, this 192, that is my sale price. That's not my original price. That's the sale price. I don't have the original price. The original price is what I'm trying to find. So we're going to let X equal the original price. Right? So there's my original price. Now, how do you calculate the discount? Well, the discount we calculate like this. We take that percent and we multiply by the original price. So when you're applying a discount or when you're applying a markup, so if you're in retail and you're marking up an item to sell it to make a profit, you multiply it typically by the original price. So that's what we're going to do here. So our original price we don't know is X. I'm going to subtract that 40% and I'm multiplying, I'm going to fix this in a second. I'm multiplying it by the original price, which is X. And my sale price is $192. Now, also when working with percents, we never work with them in percent form typically. In our example a couple of videos back, I know we did have percents there, but if you notice, we end up just using the whole numbers because those were the units we were given. When we're working with things like markup or discount, we always convert our percents to either decimals or fractions. So what we're going to do is I like to use decimals personally. So to go from a percent to a decimal, we move the decimal point 2 spots left. So if you have any sort of calculation to do like this, where you are multiplying an original value, then you are changing that to the decimal or fractional form. So I'm going to take this 40 and move it 2 spots to the left and put my decimal point right there. So my equation is actually going to be x minus 0.40 x equals 192. Now, if I combine my terms here, there's a 1 in front. 1 minus 0.40 is 0.60. And hopefully this makes sense. So think about it. If the value is 40% off, well, 100% minus 40% is 60%. That's where that 60% comes from. And now I can go ahead and keep solving. Let's see where my work is. There we go. I'm going to divide both sides by that 0.60. And I get x equals 320. So think about your question. Our question was, what was the original price? So the original price was $320. Give this a check, right? Make sure it makes sense. So think about this. Our original price should definitely be bigger than the sale price. So this makes sense, 320 compared to 192. The other thing you could do is you could take that 320, and I'll just do it on my calculator with you guys. So I could take that 320 and multiply it by that 40%, that 0.40, and I see I get a discount of 128. And then if I subtract 320 with the 128, I do get that sale price of 192. So it checks out that way as well, taking that 40% off from the 320. So with each of your examples, remember, you just want to give it that quick check at the end. Make sure it makes sense. There's no perfect check for word problems, unfortunately, but you can at least make sure your answer is logical and read back through, make sure you haven't missed something. Find a way to check it and see if it works. Now, for this example here, this is sort of a beginning investing example. Investing gets very, very complicated. So honestly, if your grandmother needed your help and had $150,000, the best help that you can give her is to say to go to a financial advisor, go to a professional who knows what they're doing. But we're going to do this just kind of for fun, for a little bit of practice to get going. But do know that investing is actually significantly more complicated than this. This is just sort of like a beginning example here to get going. So little fun note, unless any of you guys are going for, investing and, you have your experience and that's different down the road, right? But if you're new to investing, send your grandmother to somebody who knows what they're doing. So let's say we have $150,000 to invest. And we want to invest it specifically into 2 different accounts or 2 different funds. So perhaps she's already done the research. She knows, nope, these are the two that I really want. I don't want to talk to anybody else. Can you just help me set it up? What should I do? So there's a money market account that pays 1.5% annual interest. And then there's also a certificate of deposit, also called a CD, paying 1.3% annual interest. These are very low interest rates. What you usually find when investing is that the lower the percent return, usually the safer the fund, whereas your higher interest returns tend to be more volatile. So there's more of a chance of losing money. So it looks like your grandmother's being smart at least, and she knows she wants to keep it in some safer funds where she doesn't have a high chance of losing her investment. She told us she wants to earn $2,000 per year in extra income from these investments. So she's looking to earn $2,000 in interest from these investments. And of course, these are estimates. So CDs are pretty guaranteed, but if you have any sort of investment in like a stock market or a fund, that percent is not guaranteed. It could change from month to month or year to year. So it's just something to keep in mind if you're actually really investing in the stock market. They should not be guaranteeing you any sort of annual return. In the long term, stocks have done very well, but from like a quarter to quarter or a year to year, you really don't know what's going to happen. And we want to know how much should be placed in each investment. Okay. So here's our goal. Find how much to invest in the, I'm going to just label it MM for money market fund, and CD. So there's two different things we're trying to figure out here. How much goes into the money market fund and how much goes into the CD. So I sort of have two unknowns in this case. Okay. I'm going to use AMT for amount. So I'm just kind of brainstorming right now. I'm trying to get set up. Okay, how do I set this up? I know I kind of have two unknowns here, but I can only use one of them for X. Now, this is a unique example. If I read back through a few times, this is different than the first example. So if you think back to that first example we did last video, where you had the associates, the bachelors, and the masters. In the reading of that paragraph, everything kept going back to the associates. That kind of joined all of it together. I don't have that here. All it says is that part of the money is to be invested in the money market account, and the rest is to be invested in the CD. There's not really any additional information that's kind of showing me that one of these is more important than the other. So when that's the case, you're just going to choose one of them to be X. Now, how do you figure out the other part? Well, this is another common little trick that we use a lot in mathematics, is you can use a total minus your X. Notice that altogether, she has $150,000. So she's putting some in one account, some in the other. For instance, if she put 50,000 in the money market account, she would put 100,000 in the CD. Or if she put 20,000 in the money market account, she'll put 130,000 in the CD. So the two together add up to be 150. So what I can do for my other unknown is I can take that total and subtract it with my X as my setup, because together these will give me 150,000, right? So whatever this value is, if this is 20,000, then the other value will be 150 minus 20,000. So together they still give us that 150. And this is kind of a nice little trick that we use sometimes, where we have a total and we kind of don't really know what to do with it. We don't really know how to set it up. So this is a good little trick to kind of keep in mind as you're going through other examples as well. All right, so let's keep going. So the other big thing I know is that she needs to have $2,000 in extra income. So in finance, we tend to call this interest. That's the extra money that we would make from these accounts and these investments. So what we're saying here is that the interest from the money market account plus the interest from the CD must be $2,000. So she needs an extra $2,000 a year. That's what she's looking for. All right, just give me, I'm going to pause the video for 1 second, go plug in my computer. Okay. And we're looking for a total of $2,000 a year. So she needs that extra income. How do you calculate interest? Now, like I said, interest is actually quite complicated. So we're using a very, very basic method here. But we have a simple interest formula. And it's called simple really because it is a more simple formula. Where we take our principal, we multiply it by our rate, and we multiply it by our time. And usually we label this as I over here. Now, in our particular example here, our time is just 1 year, right? Because she's going to do this annually. Annual means 1 year or yearly. So the T is not going to come into effect here because that's just going to be 1. So we need that principal, we need our rate. So your principal is how much you're investing in this case, and your rate is your percent. So a rate is another way to think of a percent. So from the money market account, to calculate this, we take the amount invested. So amount invested in this case, that's your principal. And we multiply it by our rate, our percent. So from the money market account, we're investing X dollars. And our rate here is 1.5%. I'm going to go back and fix this in a second. And then from our CD, we're investing 150,000 minus X, and our rate is 1.3%. So that's the P and the R. Again, T is not going to matter here because it's just for 1 year, so it's times 1. This is the general formula that we're using. And now I'm just going to clean this up. So don't forget for percents again, if we're doing some sort of calculation like this, we do need to put it in decimal form, and we can add a little 0 in if we need to. So what we're really doing here is we're taking 0.015 and we're multiplying it by X. Here we're doing 0.013, multiplying it by 150,000 minus X equals 2,000. So this is the general setup you're going to use for this style problem here. I'm just rearranging the numbers. I tend to like my X's on the right, and multiplication can be rearranged, so it's fine. Now I'm going to go ahead and solve. So I'm going to go ahead and multiply this through. And let's see, 0.015x. 0.0113 times 150,000 is going to be 1950 minus 0.13x. I'm going to combine my like terms here, and I'm going to get 0.002x. And then I'm going to subtract that 1950 from both sides. And I'm going to go ahead and divide. And I get X equals 25,000. So I'm going to go back to my setup here and plug those values back in, right? So just looking at it here, so for the money market fund, it was just X. So I'm going to invest 25,000. And for the CD, it was 150 minus X. So I am going to take that 150,000. I'm going to minus that 25,000. I'm going to get 125,000. So you're going to tell your grandmother that she's going to invest 25,000 in the money market account and $125,000 in the CD. And that will guarantee her that $2,000 that she wants a month. Okay. Again, assuming the rates don't change and these are locked in theoretically. How can you check this? Well, a couple things. One way is if you add your two investments, they should obviously give you 150,000. And then another way you could check that, I'll just take out my calculator here, is you actually could re-multiply out these percents and make sure you get 2,000. So for instance, the money market fund is the 1.5%. So if I do 0.015 times 25,000, I get this much. And then if I do 0.013 times that $125,000 investment, I get this much. And if I add those together, we get the $2,000 that she's looking for. So I can go back and kind of plug in my two investments and multiply them by those percentages to make sure I get that correct interest rate, or that correct interest. So this is example 5. This tends to be one of the harder ones here. So there's a couple tricks you need to keep in mind. The first one is that you have this new idea of using the total as helping you to define your variables. So that's a new idea here of having one of the variables be X and one be a total minus X. And this is helpful, particularly if there's nothing that's really signaling to you that one of these is more important than the other. The second idea you have here is a new application of the simple interest formula. So you're taking that principal and your rate and you're multiplying them together. So that's, again, a new application here.